Okay, so the first page, we learned how to set up the hexagon for remembering the trig identities quickly, and we used it to find the 12 quotient identities and the 6 reciprocal identities. So now on the second page, we're going to use the same hexagon now to find the product identities. And the product identities, I think of them kind of like a hinge. So the whatever vertex you pick, like the sign, for example, would be equal to the product of the two vertices immediately to the left and the right of that center. So it's like sine is the hinge between tangent and cosine. And that would mean that the cosine times the tangent then is equal to the sine. Okay, if I use that relationship for the cosecant of x, right, here's my cosecant vertex, and so I go out from there to the right and left, and that means it's the product of the secant and the cotangent of the angle. So the cosecant of x is secant of x times cotangent of x. Okay, if we use that relationship with the tangent, so here's my tangent vertex, I go like a hinge right out to the left and the right, and that's the product of the sine times the secant. Okay, then cosine is going to be the product of sine times cotangent. Then the secant is the product of the tangent times the cosecant. And the cotangent is going to be the product of the cosine and the cosecant. Okay. Now, if we look through the center, right, the 1 then in the center is sort of like that hinge. So 1 would be the product of tangent and cotangent. So if I follow that pattern out this way, 1 would also be the product of sine and cosecant. So sine of x times cosecant of x is also equal to 1. And then 1, if I go out this direction, would be cosine of x times secant of x. So cosine x times secant of x is also equal to 1. Okay. Now at the bottom of that page, we're asked to look at the cofunction identities. And cofunction would be the relationship between sine and cosine, right? Here the co in cosine, that's its cofunction. Tangent and cotangent, those are cofunctions. Secant and cosecant, right? Those are cofunctions. And their identity relationship goes across straight through the hexagon, right? So from sine to cosine, from tangent to cotangent, from secant to cosecant. Okay, so to review that cofunction relationship that we talked about in earlier units, remember that whenever you had a right triangle, we had a relationship that talked about the sine and the cosine of its complement. Okay, so the sine is the opposite over the hypotenuse. So the sine of 30 degrees would be 4 over 8, which is 1/2. Okay, the cosine of its complement, so the complement, remember, is the 90 degrees minus the angle that you're starting with. So the complement of 30 would be 90 minus 30, which is 60. So this is the complement up here, 60 degrees. So we'd be looking for the cosine of 60 degrees. And cosine is adjacent over hypotenuse. And so we have 4 over 8, which is 1/2. And that means that the sine of the angle is equal to the cosine of its complement. So the sine of x is equal to the cosine of 90 minus x. And that's a cofunction identity that we learned in a previous unit. And we can verify that in our calculator. If we're in degree mode, we can try it out with a few other types of angles. So for example, the sine of 52, right, is going to be a wonky decimal. And if we try this cosine of 90 minus 52, we should get the same wonky decimal, and we do, right? So that's a cofunction relationship. Okay, our cofunction relationships on the hexagon, they go straight across. So if you look at that diagram, right, we see that sine is equal to the cosine of 90 minus the same angle. Tangent is going to be the cotangent of 90 minus that same angle. Secant is going to be equal to the cosecant of 90 minus that angle. So if we use that relationship going from left to right, right, we get sine of x is equal to pi over 2 minus x if we're using radians, right? Up here it gave it to us in degrees. Okay, the cosine then, if I go the opposite direction, right, I can go right to left instead, would mean that the cosine of x is equal to the sine of pi over 2 minus x, right? Then for the tangent would be equal to the cotangent of pi over 2 minus x, or if I go the opposite direction from right to left, then the cotangent of x is equal to the tangent of pi over 2 minus x in radians. Okay, then the secant is going from left to right, so the secant of x is equal to the cosecant of pi over 2 minus x, and then the cosecant would be going from left to right, and the cosecant of x is equal to the secant of pi over 2 minus x. Okay, and those are the 6 cofunction identities.